Hello everyone, and welcome back to our channel. In today's episode of
Wow! How'd you code that?
We're solving Leetcode's Compare Version Numbers challenge. This challenge has a medium level of complexity. The problem statement reads, compare two version numbers, version 1 and version 2. If version 1 is greater than version 2, return 1. If version 1 is less than version 2, return -1. Otherwise, return 0. You may assume that the version strings are non-empty, and contain only digits and the dot character. The dot character does not represent a decimal point, and is used to separate number sequences. For instance, 2.5 is not 2.5 or halfway to version 3, it is the 5th second level revision of the second first level revision. You may assume the default revision number for each level of a version number to be 0. For example, version number 3.4 has a revision number of 3, and 4 for its first and second level revision number. Its third and fourth level revision numbers are both 0.
The solution to this challenge utilizes a string tokenizer, which is used to split our strings by the dot delimiter. First, we import the string tokenizer from the Java util package. Next, we initialize 3 primitive integers to 0, result, which represents the result of this algorithm, left, which represents a count of the total number of major and minor levels in version 1 as compared to version 2, and right, which represents the count of major and minor levels in version 2 as compared to version 1. Next, we instantiate two string tokenizers, containing the values of version 1, and version 2. Next, we instantiate a string tokenizer, named tokenizer, which contains the value of version 1 or version 2, whichever has the most number of dots, determined by the count tokens method on each of the tokenizers. While the tokenizer has tokens, we initialize a primitive integer, named left1, to 0. We then make an attempt to convert the next token in the version 1 tokenizer, to an integer, and assign it to left1. If this process fails, we catch the exception, resulting in left1 containing the default value of 0. Next, we initialize a primitive integer, named right1, to 0. We then make an attempt to convert the next token in the version 2 tokenizer, to an integer, and assign it to right1. If this process fails, we catch the exception, resulting in right1 containing the default value of 0. If the value of left1 is less than the value of right1, we increment the value of right by 1, and decrement the value of left by 1. Otherwise, if the value of left1 is greater than the value of right1, we increment the value of left by 1, and decrement the value of right by 1. If, at any point during the loop, the value of right is greater than the value of left, or, the value of left is greater than the value of right, we break the loop. Upon completion of the loop, the value of 1 is returned to the caller when left is greater than right, or -1 is returned to the caller when left is less than right, or 0 is returned to the caller, when right and left are equal.
We hope you found this video helpful. If so, please comment below. If not, well, comment below, nicely. We hope to see you in the next episode of
Wow! How'd you code that?